The time has come, thought my cat Martin, and he peed in my slipper. No, I didn't want to start a grand tale about time with this, but with a vivid quote from a famous person. But reality makes its own adjustments. So while my slippers are drying, let's begin. Did you know that your feet are younger than your head? Or that simultaneous events for you are not necessarily simultaneous for everyone else? If not, you should watch this video, created especially for those who think time is something ordinary and mundane, and that it always flows uniformly in one direction. This video will change your perspective on time. Its mysteries are so grand and impressive that it's hard to believe them. However, in such a strange universe, we live. So, in most people's understanding, time is divided into the past, present, and future. The past is what has already happened. It's a collection of events, memories, and experiences. We can explore the past through the lens of history, analyze it using science, preserve it in our memory, and recount events. The past provides us with context and shapes our existence, influencing our decisions and choices. The future is what has not yet happened. It is full of possibilities and uncertainties. We plan our steps, dream of achievements, and set priorities. The future is a source of our hope and fear, as we do not know what it will bring. But all our decisions, plans, and dreams are realized in the present time, aren't they? Here arises the first question. What exactly is the present? Theoretically, the present seems to us to be the most real part of time. It is what is happening right now, at this moment. But when we try to fix the present moment, it has already turned into the past. Time, like an arrow, flies forward. Albert Einstein once said, "The distinction between the past, present, and future is only a stubbornly persistent illusion." This statement makes us wonder whether the present time really exists as something separate, or is it just a fleeting transition from the past to the future? Philosophers and scientists have long debated the existence of the present moment. According to some philosophical concepts, the present is merely a point of intersection between the past and the future, which itself has no duration. As soon as we try to fix the now, it already becomes the past. So it turns out that time is a line composed of points of the present that do not actually exist. It seems my cat Martin almost fainted, imagining a sausage made up of pieces that cannot be eaten because they are unreal. But no, he didn't faint. He's yawning. What does he care about any non-sausage secrets? One of the brightest paradoxes of the present moment is that we cannot measure it. An attempt to determine the exact moment of now immediately turns it into the past. Thus, the present exists only as an illusion created by our consciousness, which continuously updates our memories and expectations. Physicists and neuroscientists also study our perception of the present time. One such experiment is the study of human reaction time. It turns out that our consciousness needs a few milliseconds to process information and form a sense of the present. This means that our perception of now is always slightly delayed and is a construct of the brain, not a real moment in time. That is, we are already thinking about now when that now has become the past. The present moment is a mysterious and elusive part of time. It simultaneously exists and does not exist, constantly slipping out of the control of our perception. People have been trying to understand the mystery of time since ancient times. Aristotle considered time as a measure of change, believing that time exists only in connection with movement and changes in the world. For him, time was a continuous line that connects the past, present, and future, and it can be measured only through changes in objects and events. This is how most people perceive time. Plato, in his dialogue Timaeus, had a different view of time. He considered time to be a circular motion, created along with the universe as the movement of celestial bodies in space. For Plato, time was a reflection of eternity, which is unchanging and perfect, allowing us to be aware of changes and movement in the world of material things. Martin the cat also circled before noticing my slippers. It seems he is a follower of Plato. After the era of ancient philosophers came the time of scientific and technical development. In his book Mathematical Principles of Natural Philosophy, Isaac Newton described time as an absolute, independent of any external factor's quantity. This concept became the foundation of classical mechanics, where Newton defined our perception of time as uniform and unchanging, independent of events in the universe. He believed that there is absolute time, a universal measure of duration that does not depend on the observer or events. It was clear, beautiful, and understandable, and absolutely wrong. Humanity remained in blissful tranquility until 1905, when Albert Einstein first presented his special theory of relativity. It stated that the laws of physics are the same for all inertial observers, and that the speed of light in a vacuum is constant for all, regardless of their motion. The speed of light is the maximum allowed speed in our universe. Nothing can move faster. Translating the postulates of the theory from scientific to human language. Whether you stand still or fly somewhere at any speed, it doesn't matter. Your movement does not affect the fact that the speed of light approaching or receding from you will be the same constant value. It looks something like this. Imagine you are walking down the street, and a thief snatches your phone from your hands and leisurely walks away from you. A police car drives by, sees the situation, and chases the thief. Despite the speed of the police car, the thief moves away from them at the same speed. Here, military planes fly by, see all this, and also chase the thief. The plane instantly overtakes the police car, but the thief continues to move away from it at the same leisurely speed. And all this happens simultaneously. That is, you see the back of the thief not far in front of you, moving away. The police and the military also see a similar picture. Despite their speed, the thief calmly moves away from them. And most importantly, his back moves away from all participants at the same speed, no matter how fast they are. This can only happen under one condition. Time for you, for the police, and the military would flow differently. That is, think about it. In the universe, it is not time that has a stable speed, as it seems to us, but the speed of light. I have a small hope that the number of uses of the word speed in the next paragraph will not lead to a universal collapse. So, speed is a value that, according to our life experience, always depends on the observer's point of view. Of course, my example is simplified and somewhat distorted for understanding the principle. Ideally, the thief is a photon moving at the maximum speed in our universe, the speed of light. And when you imagine a rocket flying after a photon at almost the speed of light, the light will still move away from it at its usual speed. Trying to comprehend this, I cry, quickly wiping away my tears with Cat Martin. But for this to happen, something must change. In this case, the flow of time changes. Hence the twin paradox, a thought experiment proposed by Einstein. Imagine there are two twins, Rick and Morty. Morty stays on Earth, while Rick goes on a space journey on a very fast ship that travels almost at the speed of light. Rick travels for a few years and then returns to Earth. Due to the peculiarities of the theory of relativity, time for Rick, who was moving at high speed, passed more slowly than for Morty, who stayed on Earth. Thus, when Rick returns, he finds that Morty has aged significantly, while he himself has aged much less. Although they were of the same age when Rick went on his journey, now Morty looks and is older. Einstein's theory was incredible, new and bold. I have no idea how humanity did not scream in horror and run to Martin the cat for explanations upon hearing it. It was an absolute surprise. It's like explaining to physics students that Santa not only exists but also flies on a dragon. Next, let's consider another thought experiment. A train platform with an observer standing on it. A train is quickly passing by. In one of the carriages, there is a passenger with two laser guns aimed at the beginning and the end of the carriage. When the carriage passes the observer, the passenger simultaneously fires both guns, breaking the windows at both ends of the carriage. For the passenger inside the carriage, both shots happen simultaneously. The laser photons travel from him to the ends of the carriage at the constant speed of light and cover the same distance in the same time. However, for the observer on the platform, the picture is different. He sees the passenger shooting. According to Einstein's theory, the speed of light for the observer is also constant, but the train is moving. The beam aimed at the front end of the carriage chases the receding doors, while the beam aimed at the rear end meets the approaching doors. Thus, the beams have to cover different distances, and for the observer, the glass shatters first at the rear end of the carriage and then at the front. Thus, events that appear simultaneous to the passenger occur sequentially at different times for the observer. Now both I and Martin the cat are crying, although he seems to be crying with laughter, probably peed somewhere again. Elusive rascal. Too bad I didn't name him Photon. Think that's all? No. To complete our confusion, Albert Einstein in 1915 presented the general theory of relativity. It once again stated that time is not an independent and absolute quantity. Instead, time is part of a single four-dimensional structure known as space-time, where the three dimensions of space, length, width, height, are combined with the fourth dimension, time. Space and time become interdependent, and changes in one affect the other. Moreover, massive objects warp space-time around them, and this warped geometry affects the movement of objects and the flow of time. The stronger the gravitational field, the slower time flows, known as gravitational time dilation. What does this mean for us humans? First, your feet are younger than your head because they spend more time closer to the massive object, the Earth. This difference is extremely small, but practical cat Martin moved closer to me to stay young and beautiful longer. But what if we talk about more massive objects? Let's imagine 2 points, one on the Earth's surface, the other somewhere near its center. The amount of mass around each of them is different, so the time for them will also flow differently. Scientists have calculated that the Earth's core is younger than its crust by 2.5 years. Can you imagine that? We sit here and tell ourselves that 4.5 billion years ago Earth appeared, but not all at once, at first just its shell. The, so to speak, egg white and yolk formed for another 2.5 years. Nonsense. According to Einstein's theory, no material object can reach the speed of light, because as it approaches this speed, time would slow down more and more for the object flying, and the need for energy to accelerate would increase to infinity. But what about photons? A photon is an elementary particle that is a quantum of electromagnetic radiation, that is, light. A quantum is the smallest possible indivisible particle, the building block of light. A photon has no rest mass, but has energy and momentum. From the point of view of Einstein's theory of relativity, for a photon moving at the speed of light, time does not exist. For a photon, the flight from any point A to any point B happens instantly. But a photon has momentum and energy, which allows it to transfer its energy to other objects upon interaction. Thanks to this, for example, we can see the world when photons hit our retina. However, how an immaterial particle, for which time does not exist, can influence the material world, I do not understand. I'll ask the cat Martin when he dries out. Alright, what about black holes? Black holes are among the most mysterious and fascinating objects in our universe. They are giant clumps of mass. Their gravitational field is so strong that not even light can escape their grip. But how do black holes affect time? Let's take a closer look at this question. According to Albert Einstein's theory of relativity, time and space are linked into a single structure called space-time. Massive objects, such as black holes, warp the space-time around them. The stronger the gravitational field, the slower time flows. This phenomenon is called gravitational time dilation. Imagine you are on a spaceship approaching a black hole while your friend remains far from it. The closer you get to the event horizon of the black hole, the boundary beyond which nothing can return, the slower time will pass for you compared to your friend. For you, time will pass normally, but from your friend's perspective, your movements and even your clock will slow down. The event horizon of a black hole is a sort of boundary. Everything that crosses this horizon disappears forever inside the black hole. To an external observer watching an object approach the event horizon, this object will appear to slow down more and more until it almost stops. This is because time for this object, being pulled by the black hole's gravity, slows down more and more. Imagine an astronaut falling into a black hole. From your point of view, observing from a safe distance, the astronaut will slow down and become increasingly red due to gravitational redshift until they disappear from view. But from the astronaut's point of view, they will cross the event horizon in a finite amount of time and will not even notice this moment. At the center of a black hole lies a singularity, a point where gravity becomes infinitely strong and time theoretically stops completely. This is where the laws of physics as we know them cease to apply, and we cannot accurately predict what happens there. A singularity can be imagined as a point of infinite density where all our knowledge of physics ceases to function. It is like a mathematical point where everything compresses to an infinitely small size. In this point, time likely stops entirely, but this is only a theoretical assumption, as we cannot observe a singularity directly. Black holes are often considered in science fiction as possible time machines. According to some theories, if two black holes are connected through a wormhole, a hypothetical tunnel in space-time, this could create the possibility of time travel. However, these are just theories, and we do not yet have the technology to create or even confirm the existence of such wormholes. Black holes not only impress with their massiveness and gravitational power, but also demonstrate how amazing and unusual time can be under different conditions. Gravitational time dilation, the event horizon, and singularity are all concepts that help us better understand how our universe functions and how time can change under extreme conditions. Though what are extreme conditions? Living with the cat Martin under one roof, that's extreme. And in our discussion about time, we cannot ignore quantum entanglement. Quantum entanglement is a phenomenon where two or more particles become interconnected so that the state of one particle instantly affects the state of the other, regardless of the distance between them. This means that changes in one particle are immediately reflected in the other, even if they are located at opposite ends of the universe. Imagine we have two entangled photons, particles of light. If you change the state of one photon, for example, its polarization, the state of the other photon will change simultaneously, no matter how far apart they are. Albert Einstein called this phenomenon spooky action at a distance, because it challenges our understanding of space and time. Can you imagine that? It even spooked Einstein. I wonder what his cat's name was, with whom he had to wipe his tears. This phenomenon further complicates our understanding of time and space, as quantum entanglement shows that information can be transmitted instantly, without considering the usual speed of light limitations. Thus, quantum physics challenges traditional notions of space and time and forces us to reconsider much of what we thought was unchanging and understood. As you can see, despite the spooky laws of physics known to us, we still know and understand very little. But we move forward, torturing our cats with tears. And what did different peoples think about time? Time is perceived differently in various cultures, and this perception greatly influences societal values, traditions, and daily life. Let's look at how some cultures perceive time. In many Western cultures, time is perceived linearly. This means that events are viewed as sequential moments on a straight line from the past through the present to the future. Linear perception of time implies progress, development, and change. People plan their lives, set long-term goals, and believe that the future can be better than the past. This approach underlies many scientific, technological, and economic achievements in the Western world. In contrast, in some cultures, time is perceived cyclically. For example, in ancient Mayan culture, time was considered cyclical, where history repeats itself at certain intervals. The Mayan calendar consisted of several cycles that constantly repeated. Cyclical perception of time is also present in Hindu culture, where there is the concept of yugas, great cycles, each with its characteristics and repeating over thousands of years. This approach to time influences people's worldview, creating a sense of eternal return and repetition of events. In addition, in many African cultures, there is a unique perception of time, where the concept of event time plays an important role. Here, events occur not at a specific moment, but when the right time comes for them. For example, an important meeting may begin only when all participants are gathered, regardless of how long it takes. This approach reflects flexibility and adaptability to circumstances. In Japanese culture, time is perceived as part of harmony and balance. The concept of mono no aware, wu no are, emphasizes the transience of life and the beauty of fleeting moments. This is reflected in Japanese poetry, art, and daily life, where people seek to enjoy each moment and appreciate its uniqueness. And that's all for today. We discussed the concept that time is not a phantom or a monolith. It is a component of our space-time and, just like space, can be independent and unique in each point. Though I have not covered all the mysteries of time, their description requires more specialized video preparation. Perhaps I will make it in the future. Criticize me in the comments, like, dislike this video, subscribe to the channel, do something to cheer up poor wet cat Martin, who suffered so much for science.